Okay, so we have been talking about gases for the last week, and we're going to switch gears and get into some details about the properties of liquids. Now, there'll be no math with this. Some of this will be a review for you. We talked about all these things in physical science, and you understand, have hopefully a better understanding of it now that you know intermolecular forces as well as you do. But just wanted to go over some general terminology when we talk about properties of liquids. Then Mrs. Marcus and I are going to have our first go at a flip grid and see how we do with this. Our end goal is for you guys to have a little fun at home and do some different experiments maybe with it and videotape one of those experiments and show us what you got. So cohesion is the attraction between like particles, and that's a general term. It could be a liquid attracted to a liquid, meaning like water attracted to water. It could be a solid attracted to some other solid. So cohesion and adhesion both are general terms that apply to liquid or solid matters, but we really are going to be using them for the liquid state right now. Adhesion is the attraction between unlike particles. So like water being attracted to food coloring, um, oil being attracted to gasoline. So different things like that. Oil is not attracted to gasoline though, sorry about that. But like maybe mineral oil being attracted to vegetable oil. So adhesion, unlikes showing attraction, cohesion likes showing attraction. Surface tension is something that we've toyed around with. Again, review from physical science here, but this is a chemical phenomenon that happens at the surface of a liquid, where the liquid at the surface becomes more dense than the rest of the liquid. This is due to an unequal intermolecular attractions that occur in the liquid. So again, we're going to have you do or have an option to do a couple of different fun things and videotape it and see what you come up with. So those are things that you maybe have heard before. Um, Ever since the beginning of this class, we have played with the concept of a meniscus, and we've talked about how to read a meniscus correctly. What we maybe have never told you is that water gives a concave meniscus, and then mercury gives a convex. Now, we don't really have any mercury sitting around in our chem storage anymore, but if I did, and if I were to pour it into a graduated cylinder, mercury would actually do the exact opposite meniscus as water. And it really has to do with cohesion and adhesion. In water, adhesion wins. And what's really going on here is the water is really attracted to the glass and actually likes the glass particles a whole lot more than it likes itself, and so it wants to climb up the sides of those glass containers. Where mercury cohesion wins in this situation, mercury loves itself, doesn't like the glass sides at all, wants to kind of ball up and pull away from the glass side containers of the graduated cylinder, and so cohesion ends up winning in this case. Just, different intermolecular forces that are at play here to cause some macroscopic types of properties that we see. Capillary action is another fun one. If you've ever put a carnation flower into a container of food coloring or colored water, you can get that carnation flower to change colors because of capillary action of the xylem and phloem that's inside of that flower stem. But what is it? It's a manifestation of surface tension by which the portion of the surface of a liquid coming in contact with a solid is elevated or depressed depending on the adhesive and cohesive properties of that liquid. So we're going to, again, let you guys have a little fun with that, hopefully, and play around with all these different concepts. No math involved. It's something that we want you to be aware of as far as properties of these liquids, but you really just covered the beast of this lab, or of this unit, I guess, by attacking the gas properties like you did. So what is it that I want you to do? I'm going to share this document with you as well, but let me open it up here. this is what we are wanting you to do. So it's going to be a Flipgrid assignment. You have to do one of these. You do not have to do all of them at all. Just one. If you want to do more, great. If you come up with your own idea of these different properties and want to share that, that's totally fine. I really couldn't think of something that dealt with the meniscus other than what you've been playing with all year long, so I kind of skipped that one. But here's just some general ideas of what you could do. So surface tension, try to get paper clips to float in water. You could try to get a rubber band to float in water. If you struggle with this, look up on YouTube. There's some pretty good tips on how to make it work. For cohesion adhesion, again, these are just some thoughts. Put a drop of oil in a clear glass of water, or flip it. Put food coloring in a glass of vegetable oil. See what happens. You could put a droplet of water or a drop of water on a paper towel and look from the edge, see what happens. Put it on the kitchen countertop, see what happens. If you have a piece of wax paper, do that, or something that is very wax-like. Try putting it on that, see what happens. If you have a suction cup, put a small amount, this should say amount, not about, small amounts of water on it, and try and stick it to a surface and see what happens. Compare that to it being totally dry and sticking it to a surface to see the difference. I mean, if you, maybe I'm a little redneck with this, but I'll spit on the suction cup if I'm trying to get it to stick to a window. Why does that work? Like, why does that help compared to just being totally dry? So with all of these, whatever you pick, we want you to explain what's going on to make it work. See how many water droplets you could fit on the surface of a penny. Give us a video. Tell us what's going on. Why does it look the way that it does? Capillary action. Maybe try to come up with something that looks like this. So set up an experiment. That's a paper towel that's there. The colored water on one side and videotape what's going on. You might have to do a quick time lapse type of video because we don't want these videos to be too terribly long. We might have to look at 100 of them, right, Miss Merkus? I only have to look at 20 though. You can have fun with it. Maybe you want to mix a color. So like this could be red and this one over here could be yellow. So you could have a third cup and then another paper towel and have them come into this cup and see what you end up with. So have a little bit of fun. We're looking forward to see what you're coming up with. See you later, you guys.